All right, why don't we kick it off, folks? Hello, good morning, good afternoon, good evening, everyone, whoever you may be tuning in today. Thanks for joining us. We're excited to kick off our next webinar in the series of the journey to Kubernetes. My name is Kamesh Pamaraju. I head up product marketing here, and I'm joined here with some of our regular, stalwarts, Peter Frey and Rupak, and we also have a guest, which we will introduce shortly. So our agenda, as always, is we'll kick off with introductions to the panelists. Q&A reminder, you're free to ask questions along the way. Use your Q&A button or the chat window. I will be moderating the session, looking for any relevant questions along the way, and I'll ask the panelists if it's relevant, or we'll have the full Q&A session towards the end. As always, Peter is going to kick us off with the steps to the journey to Kubernetes in production. As some of you may have been attending, this is our 6th webinar, I believe, in the series. We started this 6 months ago. Various steps in the journey, all the different implementation considerations. Today's topic specifically is going to focus on pipelines, whether that's DevOps or data. And we are privileged to have a special guest today from Lucidworks. Let's go into the introductions real quick. So we have Peter Frey, oh, by the way, I keep forgetting this. So quickly, as always, we do a drawing and a giveaway as an appreciation for your joining us today for the live session. The prize is one free online Kubernetes course from our learning partner, LearnK8s, and we will announce the winner at the end of the session. So stay tuned and stay through the end of the course, to the end of today's webinar, to know if you won a prize. Next slide. And let's go into the speakers and the agenda. Peter Frey is our anchor for this series, has been running through pretty much of the series right from the beginning. He's our CT's chief technologist, and he works with the field teams and lots of field experience and implementations. I'll let him speak to his experience shortly, but I do want to introduce our special guest today, Gerald Kanapati. He's a VP of Engineering at Lucidworks, and I believe the Chief Information Security Officer too. Lots of experience in global distributed software systems. I'll again have him introduce himself shortly. And then lastly, we also have, next slide, our founder, co-founder, and CTO at Platform 9, Rupak. So folks, I will then let you guys kind of shortly introduce and maybe give your background a little bit before we jump into the journey slides with Peter. Over to you, Peter, first.
I'll start. Hi, everybody. My name is Peter Frey. I am Field CTO here at Platform 9 Systems. I manage our pre-sales teams as well as our customer success teams here at Platform 9. I've been with Platform 9 for over 3 years now, and I am in a unique kind of position where I get to talk to our customers very frequently and our prospects. So I get to talk to a lot of different people and learn about where they are on their journey to adopting Kubernetes. And then I also get the perspective of our customers where they have implemented Kubernetes and the challenges and things that they're having after they've gone down the path. So I get a lot of kind of stories from people just beginning to very advanced users of Kubernetes and all the way through. So I'm looking forward to our talk today. Gerald?
Yeah, so I think, thanks for the introduction again. As I said, I've worked for decades now, I'm that old, in large-scale distributed systems. I've been at Lucidworks for about 6 years, and it's probably about 2 to 3 years ago that we began our journey to implementing our solution, our platform on Kubernetes. At the time, I was the head of that engineering initiative, as well as working on our cloud operations. Now I've stepped to, it's gotten, the business has gotten bigger, so I've stepped over towards a role where I'm dealing a lot more with customer deployments, which is, still obviously related to that, as well as being responsible for the security and privacy aspects of our cloud operations, which is why I have the CISO title as well.
Thanks, Gerald. Hi, everyone. This is Rupak Parekh. I'm one of the founders as well as CTO at Platform 9. Prior to Platform 9, worked on various infrastructure technologies at VMware, specifically their vCloud offering. At Platform 9, we started our journey with virtualization and cloud. But now, in last few years, we have embraced Kubernetes. We have been involved since its inception, since 1.4 of the Kubernetes product. It has been wonderful to work with the community, and I'm excited to talk to our customers like Gerald here. Thanks, Gerald, for joining the conversation, and looking forward to our chat.
Great, thanks, Rupak. So for the sort of next steps, I'm going to jump in. As companies are looking to adopt Kubernetes, and wherever you are on the journey, I find that there's a lot of there's a pattern, right? And people go through this process in similar ways as they're adopting Kubernetes. And I'm going to talk to you about some of the puzzle pieces that make Kubernetes viable in a production environment within enterprises. So I like to start with this journey. Like I said, I do talk to lots of different people. And when I get a chance to talk to them, they always tell me where they started and where they're going and where they are in this journey. But they always start somewhere, right? And it's usually enterprise architects, developers, somebody from the office of the CTO, SREs in some cases, right? And they want to figure out what Kubernetes means and how does it, how do we use it in our enterprise and what kind of difference can it make, right? So they start with, well, let's stand up a Kubernetes cluster. So they start Googling around and they say, oh, I'd like to do it on cloud, or I'd like to do it on prem, right? And then they have to make decisions almost immediately. What installer do I want to use, right? Do I want to deploy on VMs? Do I want to deploy, which CNI should I use? What is a CNI? So there's a lot of learning going on right at the very beginning. But they eventually make decisions in this place, usually pick the easiest path, and they deploy a Kubernetes cluster and immediately jumping into deploying their first application. It's usually always the Kubernetes hello world, but then there's also, Nginx. I used Nginx as my first example, but I got it up and running. It was very exciting. So then I thought, well, and our customers think, well, we should deploy something a little more complex. So they look at something like WordPress and they use a Helm chart. What's Helm and how do I use Helm? And they start figuring that out, right? And for me, when I was adopting Kubernetes, I did Helm install and I did the WordPress deployment, and it failed immediately. And I'm like, well, why did it fail? It needs persistent storage. Well, my server's got storage. Well, what is persistent storage? How do I use CSI inside of Kubernetes? So now I went back and Googled around and figured that out. And, I just found out there's this thing called host path, and I implemented it, and WordPress is up and running, and it's fabulous. There's limitations there, but, I got it up and running. It was a good start. So then our organizations go out there and they're like, well, we've got a Kubernetes cluster, we've got persistent storage. Let's look at a tier D type application. And when I say tier D, I mean something non-revenue generating. If it goes down, it's not going to kill, deeply impact the business of the enterprise that's running it, that sort of thing, right? A low priority type application. So they look at how is it deployed. Is it containerized? How do I containerize it if not? And then they work and they deploy that application. But then immediately after that, they're thinking, well, if we're running this thing in production, we got to do other things. We got to monitor this. So how am I going to monitor this app in Kubernetes? Is it different? And it is than doing things with VMs. And so I have to start thinking a little bit differently. So they Google around that, monitoring, Kubernetes monitoring, and they find Datadog and Prometheus and Grafana and a slew of other tools out there. They pick one, they find a tutorial, they implement it, and they realize, oh my gosh, I'm implementing Prometheus with Grafana and Alert Manager, but I need persistent storage for this. So maybe I want to go back and readdress that host path and deploy something a little more robust, default storage classes. So they start Googling around on that. They get monitoring up and running. And then they're moving into the next phase. Once I've got it monitoring, how am I going to capture logs? Kubernetes by default really pushes the logging system to where containers only provide, or in Kubernetes only provides one container previous worth of logs, and pods can move around from various worker nodes during their life cycle. And how do we capture and correlate the logs, as they're moving around from machine to machine, and do that sort of and have reliable logging. So, they start Googling on how do I do that, and Loki and Elk or the EFK stack or, Elastic, Kibana, and Fluidbit, right? Any of those tools come up and they all have their own install, right? And they also require persistent storage, right? So they get this deployed, they pick something, they follow the tutorial, they've got a cluster now, it's got an app, it's got monitoring, it's got logging. Sort of to the point today, and what we're going to talk about today is the CI/CD portion of the world, right? Our customers are telling us, that's great, but we need to repeatedly deploy this thing. We, continuous delivery, right? Continuous integration. And how do we do that? And that's what we're going to talk to you about today with Gerald's experiences at Lucidworks. And I'm excited to talk about that. But when they're doing this research, they say, oh, do I want to use cloud native tools that are specifically designed for Kubernetes, Spinnaker or Jenkins X? Or do I want to adapt something that I've already got? Maybe I've got the GitHub stack. Maybe I've got just regular Jenkins. And most of the times they pick what they've got, is what they're familiar with, and they adapt it to work with Kubernetes. And it usually has a method for doing that. Jenkins does, for example. So then now they're able to deploy this app over and over again. You can log into a code repository, make a change to that, commit it to the master branch, can have automation come back and then redeploy that application automatically to Kubernetes if you want to, right? And so all kinds of interesting stuff can happen at that point. After you get through the CI/CD thing, then our customers are starting to think about, well, how do we do A/B deployments? I love the fact that I can have version 2 and version 3 of my microservices running in my Kubernetes cluster. How can I redirect some of my traffic, maybe for my functional testing team, to these other new microservices while my customers are still using the old ones, taking advantage of the cloud native way of doing things, right? And then they start Googling around on that and they find there's service meshes like Istio and Linkerd. And these things really, they find are complex. They require additional sidecars and such for their, for their pod deployments. And what I find is they just want to get in production. And this is something they can add on later. So a lot of our customers think about this, look at it and skip it, and then they come back to it. Okay, moving along here, then information security set gets involved. They say, oh, you got a production Kubernetes cluster. Who's got access to that? How do you do identity management? Is it just the SRE team that can start and stop things in production, right? Is there PCI data? Do you have red and green zones defined? Are your data at rest and data in flight encrypted? And how are you going to do that if you're not? And they start asking a lot of questions that cause you to go back and maybe research your CNI. Maybe you chose Flannel and you want to switch to Calico so you can do some encrypted stuff, or network policies. And so then you start thinking about that. Anyway, these are all the puzzle pieces that you need to kind of go through to get your app in production, right? From here, customers are starting to feel pretty good. They're starting to think that they're ready. And then SREs get involved and they say, wait a minute, how do we do day 2 operations with Kubernetes, right? How do we upgrade from 117 to 118 of Kubernetes? How are we going to keep up with the pace of Kubernetes change, which releases about quarterly, right? What happens if a worker node goes offline? What happens if etcd loses quorum? All the things that can go wrong in a Kubernetes cluster. What happens if, an app running inside of Kubernetes consumes all the CPU on a box? How do you prevent that, right? And so the SREs started getting involved, and it's a tier D app, so they're probably okay moving forward, but they're really cautious about it. And this is another one of the steps there. And then, we get to the production outage, and that's when our customers really start learning about how to run Kubernetes in a production capacity. I have talked about it in the past. I won't go into the production outage, but for most of our organizations, a managed service for Kubernetes is really key for them, right? They want a fast Kubernetes deployment model, out-of-the-box monitoring and logging capacities, simple decisions for CNI and CSI, examples on how I can do CI/CD, and then they want world-class support, right? They want a customer, a company that they can go to and call when they're having troubles. My deployment didn't go right. My CNI isn't communicating out to BGP correctly. all kinds of different things, right? How do I do this CI/CD thing? So they look for that support, and they're looking for SLAs in their environment. And Platform 9 offers this. I'm not going to go too deep into that right now, but I just wanted to let you know that this is what a lot of our organizations are looking for. So this is our kind of a long-term agenda. We've done our 6 or 5 of these webinars already, where we talked about the introduction to the networking one, 5G use cases, storage, logging, right? Now we're going to talk today, focusing on that CI/CD and pipelines and what that looks like. And we're happy to have Gerald with us, and he's going to talk to some of his experiences here shortly. And then, we'll have 2 more webinars, one on maintaining Kubernetes and best practices, where we're going to invite all of our guest speakers into a single room, and we'll do a panel discussion on Kubernetes. So look forward to those upcoming webinars on March 10th and April 14th, one a month. Okay, so Gerald, maybe you can jump in and describe kind of your Kubernetes experience over the holidays and how you got there and what it looks like, all that. Thank you.
Yeah. I'm going to back up a little bit too and just tie it into some of what you said about our journey. So we Lucidworks, we are a software vendor, so a little bit different from every enterprise. And what we do is we produce and sell and operate a software platform on behalf of our own customers. What that platform does is search and knowledge discovery, the search and discovery engine for main use cases, or for, say, e-commerce search. If you go, certain websites, we'll talk a lot. That's what we'll talk about a little bit more in the today. But also things like employee knowledge management and customer care helping out. So we went through a slightly different version, let's say, of the Kubernetes journey, right? We had this platform in a traditional on-prem distributed environment. It was a fairly complex application made up of a lot of components. So, for instance, we deploy inside our solution, all as parts of it, Apache Solr, which in turn itself is complicated, as Apache Zookeeper is dependency, Apache Spark for some of the data processing, others, open source components for message queuing, as well as a lot of our own proprietary things and middleware for AI, other kinds of processing for managing the configuration and setting up things and making things easier for our customers themselves to do things. So, as I said, the key thing is that it's a complex distributed system with a lot of pieces. And in the past, the burden on managing that would be, we were selling software for on-prem deployments. And so that would be, the burden would be on our customers to operate that, figure it out, make sure it's secure, deploy that. Kubernetes was really the right thing for us to help us be able to support, and for our customers to more easily and effectively be able to just run our software in a couple ways. One is it gave us a standardized way of running and operating it for those who wanted to run it in their own environments. The other was that we ourselves, a few years ago, realized that we would need to start running it on behalf of them in a managed offering as well. So we would, we ourselves operate our own versions of it in the cloud. We run a cluster for each of our customers, not all of our customers, but several of our customers have chosen to take that, and we operate those for them. It was, in the old version, it was really hard for us to support. When we did the conversion and re-architected the software, I mean, it wasn't a complete re-architecting, but it was really kind of wrapping it, following a lot of the best practices for creating container native applications that not necessarily all of our components followed, and then putting things like monitoring infrastructure, implementing within the software things that we previously had just kind of left to the customer, things like storage management and scaling and things like that, were things that now that we could do and embed into the software that we actually delivered to customers. one of the things that was great about, we were working with Platform 9 on delivering a version of this, is that a lot of our customers, they're large enterprises, but everyone's at different stages of their life in the journey with Kubernetes. So, we're selling and providing software to some on-prem customers. They aren't necessarily ready to take on and run Kubernetes. One of the things that worked out well for us was that Platform 9 was able to help us package and create a version of our product that could be run for somebody who wanted to continue running this on their own premises, in their own data center, or in their own private cloud. In their own data center, but didn't necessarily have the expertise or the comfort level of running a Kubernetes cluster along with the requirements that we had on it. So this was it was a big thing for us. These days, we're at the point now where it's that's our offering is a standard, is a package, and we've given our customers a few ways of doing it. One is they can run it on their own in their own Kubernetes cluster. The other is that Platform 9 can provide them with the packaged Kubernetes to run in their own environment. And the third way is that we would run it in our our software as a service platform where we manage and run it, and they simply access it over the internet via APIs. So that's where we came from. So do we want to? Yeah. So we'll and during the fireside talk, we'll talk a little bit more about the details of this. So next slide, please. Yeah. So one of the stories I wanted to tell was really about our retail customers. We have a large set of retail customers. Retailers were, well, not all of them, but with some of these retailers were very, very comfortable with moving to our managed and cloud-based model. But this year, this retail season, so this was sort of it wasn't our first season, but it was our first big season with like a large number of retail customers that we were managing. And this year was especially big because it turned out that online e-commerce was a lot bigger, because e-commerce got a lot bigger over 2020. And then on top of that, the retail season was always bigger. But those of you familiar in retail know that consumer retail is a lot bigger over the holiday seasons, and they get most of their business there. The trouble was that in 2020 it was a lot more unpredictable. We knew it was going to be bigger, knew it was going to be bigger than in previous years, but because of COVID-19 pandemic, people working from home, and all those changes, it was a little bit less predictable. I mean, it's always unpredictable if you're growing, but it was less predictable about what they were going to be doing. And what kind of traffic they'd be seeing and what their requirements were. So, so this year, the preparation for that season, I mean, there was always a lot of preparation, but the preparation this year had to start earlier. There's a hard deadline. You can't really slip. Black Friday happens the day after Thanksgiving, and you can't exactly say, hold on, guys, I'm going to delay it a week. So we also, the other thing is that, this is a critical time of year for all these customers. So you can't make changes if anything goes wrong, right? You've got to lock down, you've got to be sure, you've got to, it's absolutely one of those things that it has to be right, and there isn't slack. So you just have to start and prepare this early. Fortunately, again, a lot of the retailers had already started earlier. There was there was pressure to improve their online offerings and their online traffic volumes. Again, because of COVID-19, many, a lot of retailers who didn't rely as much or didn't have as much online traffic had to shift a lot more of their selling there. And so they'd already really started ramping up both the capabilities and the volumes there. So that was already in play. Now, the sort of story we need to go through was that there was the integration of a lot of different new systems. Sometimes they were new systems for those who needed to upgrade their capabilities. For others, they were a little more conservative. They weren't changing the capabilities, but they were a lot more concerned about being able to scale up and service a larger volume of customers using those capabilities. when we tested and when we deploy, or when they deploy these things, they've got their own sort of CI, or not necessarily CI. They aren't necessarily doing continuous integration, but their own integration and development pipelines on top of Lucidworks' own CI/CD. So we would have to, as a software vendor, we would deploy and push through the changes in our platform as needed to make improvements if we found bugs, if we needed to address scalability issues that were discovered by the customers. And at the same time, the customers were working outside of that loop, integrating their own system. So, we provided search and discovery, but they also had inventory, just updates in general to the product catalog, the shopping carts and things like that, that all needed to actually work end to end. So when they did their end-to-end tests, integrating our platform, they had their own integration systems that needed to cycle. Our at Lucidworks's pipeline of updating had to fit inside that loop, right? So they would like do a cycle. We had to be able to respond within the cycle of our customers themselves, and we had multiple, and the thing is, we had multiple customers as well who we would need to be able to service and be able to do this. So it was a pretty rapid cycling of things that we needed to be able to do in our cloud operations and our development team that we need to go. So the preparation was, it started, I'd say, around July, August, to prepare for things starting mid to end November. So let's move on. And so what happened? Well, let's go on to the next slide. What happened? It worked fine. Fortunately, we probably wouldn't be telling the story if it was a disaster, but it actually worked a lot better than we had even hoped. A couple of things that we did that I'll mention is, we, as I said, it was a little bit unpredictable what sort of volumes customers would see. They could provide estimates, and sometimes they're pretty good, but we're still going to estimate conservatively. Sometimes you think like we're running in large public cloud environments, whether it's AWS or Google or Azure or something, we can scale up and we can use Kubernetes auto scaling to scale up. That's not in practice for something as critical. That's okay for smaller, less predictable bursts, but when we're talking about like the major retail and shopping and revenue season for retailers, we don't want to do that. We want to be a lot more certain about that. We don't want to have the delays involved in auto scaling and those kind of like, very large and perhaps very sudden bursts there, because again, this is direct revenue that is being affected. We would have to pre-provision those resources. One of the things we do is we'd have to coordinate with our underlying cloud providers to make sure that they were able to, they were ready both for the pre-provisioned scale up that we did, as well as any sort of bursting that we might use in case things were even higher than we had predicted to auto scale up. Of course, there was a great deal of monitoring. We had our teams scheduled, our operations team running and watching. We had regular check-ins, the regular sort of operations best practices that we had, and it worked out. I think all the preparation, the ahead of time, the intensity of the testing, as well as just making sure of it, the results were a lot better than we had even hoped for. We had 0 outages. That's good. That's sort of a base expectation. But we had 0 performance drops. We met our SLAs for latency, for requirements, and for every single one of our customers. And that's important because, if you imagine you go to a website, you search for a product, you want those results to come back as quick as possible. And there's definite measurable losses in customers and losses in dollars, depending on if your response time is slow. We kept everything better than the SLAs, and I don't want to give specific numbers because different retailers actually have different SLAs and different expectations. Some of them, if they're smaller, is simpler catalogs, or different types of customers have less tolerance for it. Some of them have return more complex things that's bigger. The peak sort of volume we had in our measure is the number of queries per second. So that means that's the number of searches that somebody going to the website looking for a product in aggregate across our customers. The peak was 6,000 of those requests, which means going there, looking at what query it was, looking through the product catalog to find the matches, adjusting those best matches for what they might be looking for if it's a little bit ambiguous, or if they're misspelling things or typing things, or if there are things that need to be promoted. 6,000 of those per second at peak. Our single largest customer was over 3,000 queries per second. All the peaks didn't necessarily align for every single one of those customers. In aggregate, over the Black Friday period, holiday period, that's Thanksgiving through like Cyber Monday, 1 billion queries served across our retail customers that we've been hosting. So a great success based on us being able to operate, both prepare, and then also as it's happening, being able to use and operate the platform, have the platform monitored, being able to not worry so much about the scale through the combination of being able to scale up and be able to have intermittent load as well come up very quickly. So that's kind of the background and story. Yeah.
Joel, there's a question on the chat window that I think
sure.
is relevant. So I guess you're dealing with very large workloads here, lots of data, lots of queries.
Yep.
So the question is about how do you distribute your workload? I mean, do you create multiple clusters, or just one cluster with multiple node pools for different customers and different workloads? I think it's relevant to some folks where they have multiple business units, or they have a large corporation with several legal subsidiaries, right? That could be a similar situation there. How did you handle that in this particular case?
Yeah, absolutely. It varied a little bit depending on the customer, but our model is we actually created dedicated Kubernetes clusters for each of our customers. Now, our very largest customer, as you mentioned, did actually have multiple subsidiaries, and so they actually had 4 separate clusters for them. Most of the others, in fact, are they the only ones? I think they're the only ones that had. Maybe someone else had 2, but most of the others were not quite as large as you saw. Like our largest one is probably like half our volume. They're one of the largest retailers in the world, but we've now within each of those clusters, as I mentioned earlier, our application is a fairly complex distributed app with a lot of different components. So yeah, in fact, we did create separate node pools for each of the types of workloads. So you can imagine for retail, there's 2 sorts of workloads. One of them is the obvious one, which is people coming in and performing searches. They go and say, show me, blue socks or whatever you're shopping for, outdoor furniture or something. The other is the workload of keeping that results in the catalog up to date, right? Like, so you've got new items, you've got items sold out, you've got items with different inventory levels. So that kind of updates there. Those things, now each of those main workloads themselves is composed of different things. So one thing I don't mention that's a little bit invisible is actually we do a bunch of offline processing in order to improve the search results. So for instance, if somebody's searching for something and there are common misspellings or something turns out to be really popular, and the customer decides, hey, things that would be popular for one person looking for it, maybe that's a hot item that should be popular for more people. And so we'll take, we'll measure those signals and we'll adjust those. So there's some offline works going in there. Each of those, it is very application dependent, but we would create different node pools for those and scale those up. Now, as far as scaling, during the holiday period, like most of those workloads are fairly fairly known, right? Like we update our catalog at a certain rate. We we run our jobs for boosting and adjusting the relevancy of the results and things like that at a certain rate. But obviously the thing that varies and is less predictable is the query, like who users, when they come in, what happens in the morning, or when someone does a promotion or an email blast goes out, that kind of thing. So for that, we definitely isolated and had, and it's actually a little more complex. I'm saying there's actually multiple node pools that we would scale up according to exactly what was going on, whether it was just the data retrieval part or the relevancy, tuning via AI and so on. So yeah, that's a good question. It's but yes, we so the answer is yes, we did have multiple clusters for the very largest customers for different subsidiaries, and we had multiple node pools for the different functions within each of those.
Yeah.
So Gerald, maybe I could follow up with a question there.
Oh yeah.
I think so. First of all,
Mhm.
your customers have a production cluster, Kubernetes cluster, where they've deployed the application in, right? And it's set up with multiple node pools, so different components can scale independently through auto scaling and that sort of stuff, which is pretty amazing.
Yeah.
But I would also think that they have multiple other Kubernetes clusters, right?
Yeah.
So not just the production environment, they probably have the dev and test cluster, which might be separate from QA and functional testing clusters.
Yes,
and that sort of stuff.
And I mentioned the performance. There's a performance testing cluster as well for fire.
Yep. Pre-prod performance testing. Yeah. But as you start, as your customers have started to ramp up to Black Friday, and back to the topic of the of why we're here today.
Yeah.
I imagine the amount of change going into that environment probably ramps up as you get closer to Black Friday, changing this and applying that and reindexing this. And can you describe, what kinds of deployments, how they move from dev test to production? What tools are your customers using to push that to their production environment?
Yeah, so it varies across. It varies depending on the customer. So we, as I said, like a lot of them, some of them will use, most of them, to be honest, use a more traditional sort of development pipeline, dev, test, promotion. They'll use GitHub or some other source control system. Our software, the types of changes that they push, they're not necessarily making code changes in our software stack. They may be doing that in their software stack, so we don't necessarily have visibility to that. But as far as like our software stack, they are pushing not strictly code changes, but configuration changes, right? So the types of things where they want to, if you're a retailer, you might say, okay, I don't want when somebody searches for a category to come up so much as the specific product, or however they might want to do it. But they'll be making changes on those things. Those tended to be configuration type changes. Our software stack, fortunately, allows one to export the configuration into versionable files, basically, right? So versionable configurations, they would manage those according to their stack. Most of them would tend to use a GitHub, not necessarily GitHub. Some of them use GitHub, but like more traditional source control for those sorts of things, moving through those cycles. Internally, we ourselves, in our loop, we do actually, and this is something where over time we will change. We continue to use a non-cloud native stack as well, right? We use GitHub, we use regular Jenkins integrated in. We use JFrog for the artifacts management to manage the actual artifacts that get deployed and things like that. But yeah, so there's a wide variety, but I will say for the most part they're using a more more standard familiar sort of software stack to push things up across the environments. And for them, the nice thing is for a lot of them, the types of changes they make, they don't have to worry so much about the platform specificity. They're just looking at the configuration, and so they're able to keep using their same tools while we manage and run the deployments with the difference, with a cloud native stack. Right?
Gerald, you spoke about the complexity of the software that you deploy. Give us an idea, what does it take for you to support 3,000 queries per second for a particular customer? How many services, deployments, pod, or containers?
Yeah, so that particular customer that hit 3,000 was a total of about 1,800 CPUs. So number of nodes and containers. We have different sized ones depending on the node pool and stuff. But there are about 1,800 CPUs. Typically, we use 8 to 16 CPU container or pods rather. So those are whatever it comes out to, a couple hundred of those, like somewhere around 150 to 200 of those. But 1,800 CPUs is probably the sort of baseline measure. If we look across all of them, you can roughly double that. Our second largest customer, I think, was something like, actually it's probably more than double that because we had more excess capacity around there. And as I said, the peaks didn't necessarily align at the same times. So our second largest was probably around 1,200 or so CPUs. So these are pretty big clusters, broken down according to our application.
And you spoke about two kinds of workloads: the surge and then some kind of an update.
Yeah, I mean, you can think of it. Ours is a fairly sophisticated, like data, store and then retrieve, right? So those are the workloads, right? Yeah.
Yeah, and so when you spoke about node pools, were you using different types of virtual machine instances?
Yeah,
those?
Definitely. Yeah, definitely. We do. So so our sort of very lowest level foundational is based on Apache Solr, which is a open source search and retrieval engine. That's where the data actually gets stored, and that's sort of the base of actually fetching and retrieving data from. That is, and those do require persistent storage as well, you can imagine. So, right, so we have persistent disks on those. Those are kind of at the base. They're fairly, I believe that we use, those are 16 CPU, 8 or 16 CPU machines, depending on which customer we have. We tune a little bit differently with sufficient disk attached to those. That one tends to be about half or maybe a little bit more than half of the total number of CPUs in a given cluster, because that's doing the base storage and retrieval. We have a lot of other the updates also go through there. The way we handle those is actually, it's a little bit tricky because we have some set of nodes set aside for doing updates, and this is really at the application level, but set aside for performing updates. Then they replicate their updates to the ones that perform queries to try to isolate that work. But they're similar nodes. There are others which do a lot of the processing. So we mentioned we use Spark, and we use some other ML and AI libraries that retrieve the data from those other nodes, do a lot of processing and write it back. Those ones, we tend to have more 8-core nodes. They don't have persistent storage again. They do things live and do it in memory or on ephemeral disks and then write things back. So yeah, there's a variety of those. There's a couple of other things that we use. For example, message, essentially a message queue, as well as things like just handling the user requests, looking up their configuration and things like that we do.
Awesome. I have two questions, and then Rupak, if you want to ask some more. One for you, Gerald. I find it interesting, right? In the old days of VMs, right, I've seen customers over deploy their environments by 30 to 50% to handle the Black Friday load. And maybe they use it, maybe they don't.
Yeah.
One of the things that I thought that was interesting is that you recommend not to rely 100% on auto scaling, right?
Yep.
And I wonder why. I mean, is it too slow? Is it not
Yeah,
reliable?
it's a little bit of it's a little bit of risk aversion, right? Like, and it makes sense, right? This is the this is the season for retailers where they really, consumer, facing retail anyway, where they really make their money. They don't want to run the risk, and we don't want to run the risk of, of them being unable to support any sort of sudden load. So one is like, we did want to provision enough that we would be fairly certain, but we liked having the comfort of being able to know that if things did burst up a little bit higher, it'd be okay, right? Like in the old VM world, you wouldn't be able to do that. You'd actually say, okay, well, here's what I think it's likely to be, and I'd better add like 30% just in case things get better, because I don't want to go out. They don't want to be the one where there's a story written about it on Tuesday after Thanksgiving where, their site went down because they had a big sale on whatever, right? So
Yeah, right. Cool. And then Rupak, this question is more directed towards you. I know that our own journey to Kubernetes, we deployed our Platform 9 free tier of our SaaS offering inside of Kubernetes to manage our customers. I know we got a lot of benefit out of doing weekly updates and that sort of thing.
Mhm.
Can you talk a little bit about our CI/CD process and the tools that we use internally for that kind of continuous delivery?
Yeah, sure. And we have written some blogs around it too, so do check it out on our website. Platform 9 internally we use Cicd. We used to use Jenkins at some point of time, but we moved to Cicd, and that has been the tool of our choice for a really long time. And what we have done is, over the years, our obviously the compute needs have increased. And what we have done is, it used to be a pretty static deployment for example, for Cicd. But now what we do is we create those, what they call as the workers or the agents. That's a terminology, it depends upon the Jenkins versus Cicd. That's the terminology that they use. So whenever you're firing builds or you're trying to deploy certain things, they will actually go and create containers and pods inside Kubernetes. So it's dynamic, and you can consume as much resources as you want in that particular cluster. B, which I think is a bigger benefit, is the ability for you to have those containers pre-packaged with everything that you need. So for example, if your development team is using Java, a specific version, or Go, a specific version, then what you have is a pre-packaged container, and every time you deploy, it has on everything latest.
Mm-hmm.
And that has helped us a lot. In past, we used to have, we don't have, this particular product now needs Go 1.15, but we only have Go 1.13 in our agent. So, and we will have to retire that agent, update that agent, and then push it back. So none of that. We go and create a container image with the right tools versions, and then push it into our Docker, which is again another build itself. Right. And then now when our build is going on for the new tool, for the new product, it always picks up the right version.
Yeah. Let me just say that we've seen obviously those benefits are great, and actually even at a higher level for our developers as well, because like we're, as I said, we have this distributed application. So even within having a standard container is nice, but like what's really nice is that with Kubernetes we could have a standard Helm chart with multiple containers and all the dependencies. So it's not just, I'm running Solar version 8.6.3, and then I've got Zookeeper 3.4.12 or whatever it is. And when one of those comes up, a particular developer who's not working on that doesn't need to worry about it. They can pull up the whole Helm chart. And so it actually works, it works at the level of the container, but it also works at the level of I mean,
Your
which is
application.
kind of the story. It makes the whole application, when you're working with distributed applications, work that much better as well.
Yep, absolutely. So that was the integration piece. The other piece to Peter's question was the deployment itself. And that's another interesting story where in past, a few years ago, we used to have virtual machines deployments, and each virtual machine would have about 30 to 35 microservices running. And over the years, we have changed it to Kubernetes, to Gerald's point. Essentially, it's a Helm chart, 35 services. And two things happen. One is because of these microservices and the Kubernetes ability to deploy it on a cluster, we are able to reduce our time for deployment to from I would say 40 minutes to maybe less than 5 minutes. And a lot of that is really just downloading the container images. And that has been a huge benefit. But the other one is really going back to the microservices. Hey, you only have bug fixes in this particular service, and you're just able to upgrade that service without even a downtime. So those two I thought was just amazing and eye-opening for, we knew about it, but to experience it in practice and reduce the downtime and serve our customers was pretty eye-opening.
Rupak, do you have any best practices around CI/CD and pipelines?
We touched upon some of them, and everyone's situation is different. As I said, we have moved to using Cicd in our case to containers. I would highly recommend, even if you don't care about increasing the number of builders and coming down with it, even if you don't care about it, just the fact that you're able to version control your Docker images, because Docker file is essentially is a text file. I think it's a huge benefit, and I would highly recommend people moving to that. So that's one. The other one is, if you have monolithic architecture or you're already moving to microservices, Kubernetes is really good at that. If you look at the experience that we have gone through, from the update time or upgrade time to smaller increments, if you're looking for any of those benefits, I would highly recommend you to look at Helm. It's pretty simple, and obviously Kubernetes itself.
Oh yeah. Yeah, I have to second that. I don't know that we would want to use Kubernetes without Helm or whatever equivalent, but something equivalent. But yeah.
Okay, we're getting close to the top of the hour. Rupak, did you want to give a 1 minute commercial on Platform 9, and then we'll turn it over to Gerald to talk a little bit about Lucidworks?
Sure. Thanks, Peter. So at Platform 9, as Gerald and Peter indicated, Platform 9, at Platform 9, we have Kubernetes as a service, as well as virtualization and bare metal. Those are the three products that we have. And what we have is an integrated platform that can run on, if you look at the bottom of the slide, on any data centers. We have customers who run on bare metal. That's the most popular offering. Virtual machines, either it be OpenStack or plain old KVM or VMware. So we can run on those. On the right-hand side are the public cloud. Lucidworks, they use public clouds heavily. AWS, Azure, and we have capability to run on other public clouds too. And the big one that we have been investing time recently is edge and retail. So what we have done is we are working with our customers to deploy compute into retail stores, and Platform 9 can help go from really bare metal servers all the way to your applications. And a very similar use case in 5G. They're very similar in operational model, where in 5G or even in other mobile communications or CDN, there are remote locations where you want to bring up your compute, where you're running your network functions or your data streaming, and all of them can be done very easily with Platform 9. So those are the kind of the infrastructure that we support. And what we really bring to the table is a stack which can, as I mentioned earlier, can, once you ship your hardware to those locations, you can take your bare metal with Platform 9, you can then install operating system. And if you want to run virtualization, we have support for both OpenStack as well as KubeVirt. Or if you want to run containers, all of them can be done by really one click with Platform 9. And then we have, we just don't stop at what I call as day 0, but we move on to day 1 and 2. So Kubernetes releases things every quarter. How do you go and upgrade them? And Platform 9 does that. We have specifically on public clouds, you want to auto scale. Your nodes can go down. You are probably using spot instances. And how do you replenish those node pools? So that's something that Platform 9 can do. And there are other interesting things specifically for enterprises. You may want to connect yourself to Active Directory or your Okta account or one login account. So we have all those enterprise features. And on top of that, we have, so that's just the infrastructure piece, Kubernetes, virtualization, bare metal support. But on top of that, we have some very, very interesting things that we have added to our platform to make the consumption of Kubernetes and virtualization is pretty easy. For example, one of the main thing that we do in bare metal is providing you as load balancer as a service, which typically is only available in public clouds. But Platform 9 ships with a component called as Metal LB. And so you can really take the same application that you're running in public cloud and you want a load balancer, it will come up automatically on Platform 9 Kubernetes. Another interesting thing that our DevOps team really like about Platform 9 is the ability to monitor their applications, connect to other logging systems that they have using Prometheus or Fluentd. For 5G stacks, for networking, we have extensive, and when we can talk about for an hour, we have extensive support for different networking things like Multus, OVS, Calico, SRIV, DPDK, and a whole bunch of other features that help you run these network intensive applications on top of Kubernetes. And the last one is probably the most interesting one for developers who want to use things like Nginx. Hey, I want to use MySQL or I want to try Jenkins, and we have spoken about that a lot in this forum. How do you quickly add that? Gerald spoke about Helm. Helm is by default supported on Platform 9. We come out with this app catalog. We have a repository of curated applications called a School Kubernetes, where you can just really point and click and say, I want to deploy Jenkins, or I want to deploy Nginx, or so on and so forth. So this is all fine, but a lot of our customers say, we don't want to use your UI because we want to integrate everything through CI/CD. And so what we have done is we have also exposed our APIs through Python APIs, we have CLIs, and we also have Terraform. So if you want to automate everything through that, that's also possible.
A quick time check, folks. We are almost at the top of the hour. Just one more minute left.
Okay.
So, maybe you just want to do quick review of how, Gerald, maybe how Lucidworks works with Platform 9, and then we can wrap it up. I do need to announce the winner, so need about 30 seconds.
Yeah, I mean, I think it says it right here. I mentioned our offering, is hosted, but for a lot of customers, they don't, they don't want to, or they need to keep their data, or they want to run everything on-prem. But they're not necessarily ready to handle managing and running a whole Kubernetes stack themselves. And so what we've done is we've worked with Platform 9 to make sure that our product, our Lucidworks Fusion, which is built using Kubernetes and Helm technologies, is something that Platform 9 can offer to those customers, so they basically can run it in their own environments, whether it's public cloud or private cloud of their own, or their own bare metal or other data centers, and be able to run our Kubernetes-based application and get all the benefits of the automation, the monitoring, and management.
Terrific. Thank you, Gerald. We are almost out of time here. Again, I'd like to thank you, Gerald, for joining us on this webinar as a special guest. I do have a winner. We have George Golden from Viasoft. I think he just dropped out. But George, we will be sending you the free course from our partner, LearnKDS, shortly. So stay tuned for that. And again, I would like to thank all of our panelists today for the wonderful webinar and in-depth conversation on DevOps and data pipelines with Kubernetes. So we look forward to seeing you in the next webinar, which should be in about 4 weeks from now, where we will cover lifecycle management of Kubernetes. So we'll see you all there. Thank you, everyone, once again, and you will get a copy of the webinar recording shortly. Cheers. Have a great day.
Cheers. Thank you.
Thanks, Sharon.
Bye, everybody.
All right.